I give a file in the materials. So you can look at the recursion section. I put one file, which is IPYNB. So you can look at the example about the recursion. So you can run in your Jupyter notebook. So I give several examples about recursion. For example, the factorial. And then I also give you the function about binary search. So this is an example about the recursion. And then I also give you the example about reverse. And also I give the example how we can do the power. Okay. Last week we also learned how to create the power if it is an odd number of n, then yeah, we can use this power. If we use the n as an even number, then we can do like this one. So POW is a function. Okay. This is a function from the Python. It is from the mathematical library of Python. So you can see if it is 3 power of 3, then it is 27. So we can just use the existing Python library to deal with this power function. I think you already know how to deal with the time. Okay, we learned about the algorithm analysis. So we can look at the time. I also give the comparison between the power function if we use every number to do the power. I mentioned it as power slope because last time we learned this one. The computing power with this function, it is O(n). But when we try to do the recursive with squaring, because we can make it half, then the big O is locked. So the time can be reduced by half. So this is the power fast. So please take a look how we can do with this algorithm, power fast. And then next, let's deal with the tail recursion. I think this tail recursion is the one that you learn about the reverse. So one more time, I will like to explain. If a tail recursion occurs when a linearly recursive method made its recursive call as its last step. So we call this is tail. Tail means at the end. So if the recursion happens at the last one, for example, if you look at this example, binary sum. Okay. So the recursion happens at the final one, but this is not linear. Okay. So for example, this one is not tail because it happens in the middle. Okay. This one is tail recursion because it happens at the end of the code. Okay. So the keyword here is it makes its recursive call at its last step. So if it happens in the last step, then it is still recursive. So the array reversal method is an example. Such method can be easily converted to non-recursive methods. So usually, if it is a tail recursion, we can make it as a for loop or while loop. Now there is another kind of recursion. We call it binary recursion. Binary recursion occurs whenever there are two recursive calls. Binary. Binary means we have two options, 0, 1. So if there are two recursive calls, for each non-base case, then we call this binary recursion. For example, add all the numbers in an integer array A. So I have this integer. It is an array or it is a list. And I want to do the binary sum. So here is A, I, and N. So input, it is an array A and integers I and N. The output will be the sum of n integers in A starting at index I. So I is the index, n is the number of elements in the array. If n equals to 1, then return A. If not, then do the binary sum with the list A starting from index I until n divided by 2. So if I have the index between 0 until 8, so the left one, this is the left one will be from I until n divided by 2. So it means it will start from index 0 until 4. So this is I and this is n. So I have 8 integers. Well, what about this one? A is the array, and then I would like to start from I plus n divided by 2. Then it means I will start from 0 plus n divided by 2, it is 8 divided by 2. Then the starting index will be from index 4. And we are going to check for 4 next integer. I can say this one. We are going to check if this is the array. So I would like to check from 0, 1, 2, 3, and then the remaining will be this one. From 5, from 4 until the remaining of the integers in the array. So this will be the left, and this will be the right section. And then we are going to check again from this one. We are going to make half. We are going to make half. Again, here we are going to make half, and we are going to make another half. So this happen to do the sum from the left, and this is the sum from the right. So we call this is the binary recursion method. Let's say I have and 4, and then 5, and 7. And then we again split to the left and to the right. After this, we will have, because this is the last one, and this is the last one, then we will do the summation. 2 plus 4. 2 plus 4 will be 6, and then 5 plus 7 will be 12. And then in order to go to the upper section, again, we will do the summation 6 plus 12. Then this will be 8. The same with the right one. We will go until the node, the last node. So 8 plus 9, it will be 17. 12 plus 14, it will be 26. Then it will go here. 17 plus 36. So it means it will be 43. And at the end, we will combine 18 plus 43. The result will be 51. 61. So if you want to know the step by step, I give you the code here. So there is one website. It is very good to see the step by step. So you can look at this step. So there will be 51 steps in total when you want to do the list sum, and this is binary. This is binary recursion. How do you know is it binary? Because there are 2 recursion methods at the last step. So you can go to the next. So you will see for every written value. So you will see every step until you got the final result, which is the summation of all the values. So the computer programming, I think you know about Fibonacci. Okay, so we also learned about the Fibonacci. Okay. So in the Fibonacci, we can also make the Fibonacci with binary recursion, or sometimes we can also say as multiple recursion. Multiple recursion means there will be more than one recursion. So for example, we know the Fibonacci numbers will start from 0 and 1. So the Fi, it will be equal to Fi minus 1 plus Fi minus 2. So if I have 0 and 1, then the next will be 0 plus 1, which is 1. The next number will be 2, because I know it will be 1 plus 1. The next number will be 3, because I know it is the result from 1 plus 2. The next number will be 5, because I know this is a summation between 2 and 3, and so on. So Fi equals to Fi minus 1 plus Fi minus 2. For I is higher than 1. Okay, so that is condition. Then if we use the recursive algorithm, we can use the binary Fibonacci given k. So k is non-negative integer. So it means a positive number. So I would like to see the k Fibonacci number. If k equals to 1, then return k. If not, here we have binary Fibonacci k minus 1 plus binary Fibonacci k minus 2. So we will do the binary Fibonacci of this one, k minus 1, and plus the binary Fibonacci k minus 2. We can do something like this one for the Fibonacci. So I give you the code as well. You can look at the code for the binary Fibonacci. So this is an example of binary Fibonacci. We know that if the recursion contains two recursion methods, okay, this is Fibonacci n minus 1, this is Fibonacci n minus 2, then this is binary recursive method. So you can see here, there are 1000 steps. So it is only for a number from 0 until 15. Only 15 numbers, but we have about 1000 steps. So it is too complex. Okay? So the algorithm is very computational cost. Why? If we do the analysis, if we do this analysis, when n0 equals to 1, then it is only 1. When we are in the n1, so it is also only 1. But when it goes to n equals to 2, now it becomes a little bit complex, because we will have n1 plus n0 plus 1. So it means there will be another number. So there will be 3 steps. What about if n equals to 3? If n equals to 3, then it means I would like to know the summation of n2. So n2, there will be 3 steps. And then I would like to do also the n1. So n1, there will be 1 step. And there will be another additional step to add the Fibonacci number. So at this, there will be 5 steps when there are 3 numbers. What about 4 numbers? So if there are 4, then we will do the n3 plus n2 plus 1. So n3 have 5 steps, n2 have 3 steps, and with additional 1 more step. So we have 9 steps. And so on. And if you plot this number, nk at least doubles every other time. If you look at this number, when it is 4, okay, it is 9 steps. When it is 6, so it is 25 steps. When it is 8, it is 67 steps. So it means, yeah, it is always almost double. Okay? Almost, it means just equivalent to double, but not exactly double. For example, 4, and we have 9 steps. So it means it is 4 plus 4, double. And then we have 6. Okay. 6 until 25, so it means there will be 4 times. And what about if the n equals to 8? So it means there will be more than 8 times. So at the end, if we do this analysis, so it is 2 power of k divided by 2. It is the exponential problem. That's why when you look at the step on the code, with only 15 numbers, there will be like more than 1,000 steps. What does it mean? It means that using binary recursion does not guarantee to get a better function. For this Fibonacci, it is too costly. It is very high cost for computation. But if you look at this binary recursion for the summation, it is efficient because we divide by 2 and we will get this one. If you look at the binary search, the result will be log n. It depends on the problem. We need to analyze it before we decide whether we will use this function or not. So this is a better Fibonacci algorithm. We call this is linear recursion. In the linear recursion, we will have only one time recursion. So here the algorithm is linear Fibonacci k, and then it is non-negative k, and the output will be a Fibonacci number fk, fk minus 1. If k equals to 1, then return k, 0. If not, then I, j will be the result of linear Fibonacci k minus 1. So you can do with return I plus j, I. So this is the code. Okay, you can look at the code here. So if you want to visualize it, you can look at the code here. And then you can visualize the execution. So with 6 number, there will be 31 steps. So you can do one by one how this code will do the recursion for linear recursion for one time, and then it will give you the Fibonacci 6. Okay, so I did not print the result, so it is just to show the step by step. If you want to print it, so you can just open this print section. Okay, so at the end, in the recursion, you learn about the basic definition of recursion, and you learn about the linear recursion, and you learn about the recursion variance. So in the recursion variance, at least we learn about tail recursion, and then we learn about binary recursion. For the tail recursion, it happens on the last step of the recursion. So it happens on the last step of the recursion. And for binary recursion, we have 2 recursive methods. So if we have multiple recursion, it means it has more than one. there might be 3 recursive methods. There might be 4 recursive methods, and so on. So what is the difference between recursion and iteration? So the recursion, it is elegant. What is the meaning by elegant? Some people say that it is easy to understand the code because you can just look at the repetition. For the performance, some problems can be solved efficiently using recursion, but others not. So sometimes the performance of iteration is better than recursion, but sometimes some problems can be solved efficiently using recursion. For example, you learn about the binary search, you learn about binary sum. So those two functions are efficient using the recursion. Debuggability. Debuggability means if you want to fix the code. Some problems in recursion are difficult to debug when it occurs error. So if you want to debug, if you want to fix the code, some of the recursion problem is difficult. So the iteration is easier to do the debuggability. Okay, so that's the end of the recursion. Let's move on the next section, which is about array. I think you know about array if you join the computer programming. We are going to learn about the sequence classes and then some type of operations and what is the meaning by growable array. Sequence classes. I think by now you know the difference between list, tuple. Do you still remember? List is a sequence of elements and you can modify the element. But tuple, it is also a sequence of elements, but you cannot modify the element. We also can use string to make the sequence valid. Each of these sequence type supports indexing to access an individual element of a sequence. So we use the syntax, for example, AI, A at index I. This is to check what is the element at the particular index. Each of these types use an array to represent the sequence. So we call this is array because every element will have a location. So an array is a set of memory location. So it is a set of memory location that can be addressed using consecutive indices. Consecutive indices means we have the index 0, we have index 1, we have index 2, and so on until index n. It is in Python, start with index 0. Okay, we know in Python, start with index 0. In Java, we start also with index 0. If you use R, it starts with index 1. Okay. Some other computer programming language, they have starting with 0. Some others, they start with 1. So please pay attention how they arrange the array. So when we do with the object, so we can also store objects. What does it mean by object? First, an array can store primitive elements. The primitive elements is just a character. For example, S A M P L E. So every character is in one index. Or it can also be an object. So in the index 0, it is a person with the name Rin. In index 1, it is a person with name Joseph. In index 2, it is an element for in the name Janet. In index 3 for Jonas. In index 4 for Helen. And index 5 is for Virginia. Yeah. Now in the Python, they have one array, or they have a module, and they call it as a compact array. What is compact array? So the compact arrays, it is a primary support for the array. That module defines a class also named array, providing compact storage for arrays of primitive data type. Do you know what is primitive data type? In programming language, the primitive data type is the data type like integer, float. So those are the primitive data type. If the data type is more complex, we call it object. So you know about the object-oriented programming. So the data is more complex. If just a number, or if it is just a letter, then we call this is primitive data type. Constructor for the array class requires a type code as a first parameter, which is a character that decides the type of the data that will be stored in an array. For example, like this one. I have a variable prime, and I would like to make an array, and the numbers or the element of the array will be I. Okay, so I means integer. It means every element in this list will be integer. Because this is compact array, because all the elements are the same data type. So I give you the code in the section of array. Now, if you look at this example, I have a data, and this data is having 3 elements, 1, 3.14, and 34. Is it possible? It is integer. Okay, this is integer, this is float, and this is string. Yeah, in a list, it is possible. So you can have this data. particular location in the array. This is index 0, index 1, index 2, index 3, and so on. If I have all the strings, okay, this is also possible. But we can use the compact array. In a compact array, for example, I'm going to use an array in the Python. If I specify I, then it means all the elements should be integer. You cannot mix with other data type. I can do this one. So the numbers will be integers. So there are some types that you may understand. B is for the signed character. Big B is for unsigned character. So we have U, Unicode character, H, short integer, big H is unsigned short integer. Usually we call unsigned, it is also including the negative number. Signed integer means just positive, unsigned integer, it includes the negative and so on. Okay. So this is the number of bytes or the number of memory that you will allocate if you use those data type. So I just show you, if you use this array, so example, this is an array of prime. Now let's have another array. I'm going to define D. What is D? Based on the definition, D is float. Then it will be an array of element float, which is 1.1, 3.5, and 4.1. Okay, due to the time limitation, I will explain more about the array on Wednesday. Thank you very much for attending the class. See you on Wednesday.